Hey everyone, welcome back to Code with Me. In today's session, we're diving into one of the most essential topics in programming, algorithms in C. If you want to write efficient programs, understanding algorithms is key. Think of them as step-by-step instructions for solving problems, just like following a recipe to cook a dish. In this chapter, we'll explore different types of algorithms, including sorting, searching, greedy algorithms, and divide and conquer strategies. We'll also write real-world programs using bubble sort and binary search to see these concepts in action. So, let's get started. Sorting algorithms. Sorting is an essential part of programming. Imagine you're organizing books on a shelf, sorting them by title or author's name. Computers do the same thing when handling large amounts of data. Bubble sort. Bubble sort is one of the simplest sorting algorithms. It repeatedly swaps adjacent elements if they're in the wrong order. Picture it like bubbles rising to the surface. The larger ones take longer to reach the top. Here's how bubble sort works. This program sorts an array of numbers using bubble sort. The nested loops compare and swap elements, moving larger numbers to the end with each pass. If we run this program with the input 64, 34, 25, 12, 22, 11, 90, the output will be unsorted array 64, 34, 25, 12, 22, 11, 90, sorted array 11, 12, 22, 25, 34, 64, 90. While bubble sort is easy to understand, it's not the most efficient for large data sets. Faster algorithms like quicksort and merge sort are used in real-world applications. Searching algorithms. Searching algorithms help find an item in a collection. Imagine looking for a name in a phone book. You either go page by page, linear search, or jump to a specific section, binary search. Binary search. Binary search is much faster than linear search, but it only works on sorted arrays. It works like this. 1. Check the middle element of the array. 2. If it's the target value, return it. 3. If the target is smaller, search in the left half. 4. If it's larger, search in the right half. 5. Repeat until the value is found or the search space is empty. Here's a simple binary search program. If we run this program with the target value 40, it quickly finds and returns element found at index 3. Binary search is O log n ta in time complexity, meaning it's much faster than checking every element one by one. Greedy algorithms. Greedy algorithms make decisions step by step, choosing the best option at each stage. This method is used in real-world problems like Dijkstra's algorithm for finding the shortest path in Google Maps. A simple example is the coin change problem. Imagine you need to give change using the least number of coins. A greedy approach would always take the highest coin value first and continue until the exact amount is reached. Divide and conquer strategy. Divide and conquer is another powerful technique. Instead of solving a problem all at once, we break it into smaller parts, solve each part, and combine the results. For example, merge sort works by 1. Dividing the array into halves. 2. Sorting each half recursively. 3. Merging the sorted halves back together. This is much faster than bubble sort, especially for large data sets. Wrapping up, today we learned about essential algorithms in C. Sorting algorithms like bubble sort, quicksort, and merge sort. Searching algorithms, including binary search for fast lookups. Greedy algorithms for making optimal choices step by step. Divide and conquer for breaking down problems into smaller parts. Understanding these algorithms is crucial for efficient programming, competitive coding, and technical interviews. If you found this video helpful, make sure to like, share, and subscribe to Code with Me. See you in the next one.